a resultant vector. You see, actually this law is called the triangle law of vectors. If you got two vectors given by the two sides of a triangle in order, then the third side drawn in the opposite order will represent the resultant of these two vectors. Now, we will deal with more of triangle vectors in the lab part of this. At the moment, I'm going to leave this here. Okay, let's do another problem. Find the vector v that has an x component 12i and a y component 5j. Well, this time I have given you the components. You need to find the vector. The x component v1 equal to 12i. And let's draw this. This is the 12, v1 equal to 12i. The y component v2 equal to 5j. Where will I draw this? Draw that from the head of the first vector. There you are. So the y component is v2 equal to 5j. And therefore, what is our vector v? Our vector v is the vector drawn from the tail of the x component to the head of the y component. We are looking for the magnitude and direction of this vector v. Magnitude is the length of that line. Direction is the angle it makes with the x-axis. Simple, is that right? Alright, the magnitude of v can be obtained. Tell me, anybody tell me, how do we obtain the length of this vector? If you look at this right triangle, you can use Pythagoras theorem to obtain the length there. So we got v squared equal to 12 squared plus 5 squared. The length of this leg is 12. The length of the second leg is 5. So the square of the length of the hypotenuse we call v squared equal to 12 squared plus 5 squared, and that is 169. Therefore, v equal to 13 units. This is the magnitude of the resultant vector v. We now need to find the angle. Anybody suggest to me how to find the angle this vector makes with the x-axis? The direction of vector v is given by the angle theta it makes with the x-axis. And how do we find that angle theta? The simplest way to find that angle is to take the ratio of the opposite side to the adjacent side. What is that ratio called? Opposite side divided by the adjacent side. It's called tan theta. Tangent of this angle is opposite side divided by the adjacent side. That is 5 divided by 12. And therefore, theta is tan inverse of 5 over 12. I hope you understand that concept. So, put in your calculator this quantity, tan inverse of 5 over 12. And keep your calculator in degree mode. Alright? And tell me what that is. Theta equal to tan inverse of 5 over 12. Keep your calculator in degree mode and calculate this. It should give you 22.6 degrees. Alright? Don't just sit back and watch this. You've got to be actively participating while you watch these lectures. Okay? So, we have now obtained that vector. That vector has a magnitude 13 units. Its direction is given by the angle theta equal to 22.6 degrees. So, very important concept. If you know the components of a vector, you can find the magnitude and direction of that vector. And conversely, if I give you the magnitude and direction of a vector, you can find the x and y components of that vector. Alright, let's do another one. Find the resultant of the vectors A and B shown in this diagram. Now look at the vectors A and B. Let's talk about the vectors A and B. Vector A has a magnitude 10 units. It makes an angle 47 degrees with the x-axis. Vector B has a magnitude 15 units and it makes an angle of 110 degrees with the x-axis. Alright, can you write vector A in the component form? In order to add vectors, we first write each of these vectors in the component form. And how do we write vector A in the component form? Well, vector A has a magnitude 10. That means its x component will be 10 cos 47 and its y component will be 10 sine 47. Look at this. A is 10 cos 47i, this is the x component, plus 10 sine 47 degrees j. Alright? Any vector can be broken into x component and y component like this. And use your calculator to obtain this value. 10 cos 47 is 6.82 and 10 sine 37 is 7.31. So our vector A is 6.82i plus 7.31j. In the same way, vector B. Vector B has a magnitude 15 units. It makes an angle 110 degrees with the x-axis. Therefore, its x component is 15 cos 110 degrees. Its y component is 15 sine 110 degrees. Therefore, vector B in the component form is B equal to 15 cos 110 degrees I plus 15 sine 110 degrees J. And use your calculator, find the value here. That will be negative 5.13i plus 14.1j. Okay? We can now add these vectors. Let me draw these vectors for you over here. If you see our first vector, vector A, has the x component 6.82i and the y component is 7.31j. And vector B has its x component, what is it? Negative 5.13i, and its y component is 14.1j. So you can now add the x components together and the y components together. You see, if both vectors are along the y direction, you can add them. So the y components can be added and the x components can be added. You can see 6.82i can be added to negative 5.13i. What would be the result? It will be a small positive vector. Similarly, 7.31j can be added to 14.1j. Alright, let's do that. So the resultant, look at the word resultant. Resultant is the result of adding vectors A and B. And look at the way I wrote it. I took the i's first, the x components first. That'll be 6.82 minus 5.13i plus 7.31 plus 14.1j. So this is the x component of the resultant vector. This is the y component of the resultant vector. And that will be 1.69i plus 21.41j. We have now obtained the resultant of A and B in the component form. We need to find the magnitude and angle of the resultant. Let's do that. So the resultant vector has an x component 1.69i and a y component 21.41j. We need to find the resultant vector A plus B, which will be drawn from the tail of the first to the head of the second. This is the vector A plus B that we need to find. The magnitude of the resultant is, now tell me, how do you obtain the magnitude? The magnitude will be square root of this square plus, you see, square root of x squared plus y squared will give you the length of the hypotenuse. The magnitude of the resultant is square root of 1.69 squared plus 21.41 squared, and that will be 21.48 units. The length of the resultant vector is 21.48 units. What is the direction of this vector? How do you find the direction? Well, the direction of the resultant is given by the angle theta here, and tangent of that angle theta is y over x. Y is 21.41, x is 1.69. So tan theta equal to y over x. Remember, we are talking about theta, this angle. Tan theta equal to y over x. That is 21.41 divided by 1.69, and you can now, if this is tan theta, theta will be tan inverse of this. So in your calculator, go and punch this in. Tan inverse of, use a parenthesis. Tan inverse, I think most calculators come with a parenthesis when you type in tan inverse. 21.41 divided by 1.69, parenthesis closed, and what does that give you? That is 85.5 degrees. So the result of adding those initial two vectors is a single vector that has a magnitude of 21.48 units and an angle 85.5 degrees.